know, we'll find out.
Oh no. Oh no. Calculator, man.
What's your like?
Ooh. Thank you. Thank you. Thank you. Alright. Let's see what some of our peers said for this first question. So remember, this question is, with your small group, identify an equation to find the missing side of number 1 on the backside of solving right triangles with trig ratios. Right? Does anyone see an equation here?
Nope. Yeah.
Yeah.
Which one?
Top one.
The top one? What is that top equation?
A squared plus B squared.
What's the name of that?
Pythagorean theorem.
Pythagorean theorem. With the Pythagorean theorem, why are you talking while I'm teaching? Would the Pythagorean theorem allow us to find the missing side of a right triangle if we have two sides?
Yes.
Yes. Notice, and this is an important detail, we're used to doing trig ratios because that's what we did so heavily yesterday, but we're dealing with right triangles. Whenever you start dealing with right triangles, there are two things you need to think about. Trig ratios is one of them. What's the other? Pythagorean theorem. If you have two sides, to find the third side of a missing triangle, seriously dude, you can't leave your pants on for a whole class? Then why are they on in the first place? Do not take your pants off in the middle of my class ever again. Is that clear? Like, we are too far into this semester for you to think that that was okay.
Everybody even know how to talk now.
I know. So, I didn't hear it, and I'm apparently glad I didn't hear it. So, let's look at these equations. And so I want to point out, if you have two sides, you can use Pythagorean theorem to find the third side. So if I had, and go ahead and write this on your sheet, because this is one of the things I'm going to ask you to do. 3 squared plus b squared is equal to 5 squared. How would I figure out what b, or someone else said x, how would I figure out what that side length is? Say again?
Oh wait, no, you're speaking.
No, I'm trying to solve for b. I don't know what b is yet.
3 squared and 5 squared.
We'll do what with them?
Whatever.
Oh, square. Yeah. So simplify. What is 3 squared?
Nah.
Plus?
B squared. 25.
Okay.
Subtract 5.
Notice, what is 9 minus 9?
0.
0.
Right? We're always trying to create those zeros and those ones using our inverses.
14.
So what is b squared?
14.
No, the square root of the square root.
You should calculate. Use your 2.
It's 3.74.
Wait.
What is b squared? 16.
How you know that?
Oh, 25 minus 9.
25 minus 9 is 16, not 14. We gotta be careful. Also, use a calculator. Don't make silly mistakes.
The square root of it is 4.
And then I would take the square root.
It's 4.
Okay? So, what is the square root of b squared? Square root of b squared. Say, I heard it. B. Remember, the b and the square root and the square, they are canceling each other. They are inverses, so I'm just left with b. So what does b equal? 4?
Yeah.
Okay. Now, I am going to cover something for just a minute that will help you if you pay attention to this next year in Algebra 1, because I do not want you going into Algebra 1 with this misconception. I need you to hear me very clearly. This will not impact how you approach this in my class, but it will impact you in the future. B squared is equal to 16. When you take the square roots, yes, you get a 4, but you actually are supposed to get two answers here. You get a positive 4. Does anyone know what the other answer would be? A negative 4. Now, I need everyone to follow this because I need you to understand why this is happening. First off, type in the square root of 16 in your calculator. Do you know how to get to the square root?
Yes.
Say again. Take the square root of 16.
4.
If you aren't sure how to do that, let me open this.
Control.
Notice there's a square above the square root above the square, so you hit Control and then the square. So I need an actual. So Control square root of 16. Okay. Y'all, listen. The calculator is only going to tell you 4 because of how we define what a square root is in a calculator. However, when we solve an equation, what are we trying to find? The what? I heard someone say it. The solution, but what does that mean?
The
Does
result.
not mean the answer.
Results.
Does not mean the result. Say it again, Zara. I'm trying to find the solution to the equation, but we are forgetting the most fundamental definition of what a solution is. I know what you're thinking. The value, let's start here. The value or values that makes the statement true, which is what Matthew was saying. Listen to me again on this, because this is an important detail. A solution is the value or values that makes an equation true. You cannot forget that fundamental idea. So remember, I started off with b squared equals 16, correct? Does 4 squared equal 16? Pick up your calculator, put the parentheses, take 4, square it. Does it give me a 16?
Yes, it
It does, doesn't it? Now, test the negative 4. Does negative 4 squared equal 16? Boom. Nope. Nope. You need to put the parentheses around that negative 4. Negative 4 squared is in fact, Dee Dee, is there something wrong right now?
No, ain't nothing wrong with me.
Dee Dee,
Oh, no, what?
Dee Dee.
It is 16.
I got
It is 16.
What I do wrong?
Put them away.
I'm saying how.
How what? So, first off, if you were to pick up a calculator and do negative 4 squared, it would tell you 16.
I have from 2.
I'm not telling you, I'm telling you the calculator tells you. But, what does it mean to square something?
Times by itself.
Multiply it by itself. Kaylin, that means it's negative 4 times what?
I was stupid.
Kaylin, I'm literally in the process of answering your question. Alright, cool. Keep your head down then. What? Negative 4 times what? Times negative 4. What's negative 4 times negative 4?
16.
That's 16. That is why, notice the calculator doesn't recognize this right away. You have to recognize that when you take a square root, it's going to be both positive and negative. Now, that is the truth of how to solve an algebraic equation. But let's take a step back and look at this. What we're trying to find is the length of a what?
Angle.
Length
Side.
of a
Side.
side length of a
Side.
triangle. Thank you. So what we had was this triangle. It's a little off, but 3, 5, and then a side length here. Can the side of a triangle be negative?
No.
Yes. No. Maybe.
No.
Can length be negative?
No.
Yes.
Okay, let me ask you this then, Matthew. Have you ever talked to your parents on the phone and be like, hey, Mom, Dad, I'm -5 miles from the house?
Yup.
Have you ever done it?
No.
Do you know why? Because length or distance is not
Negative.
negative. Does that make sense, then, Matthew? Okay, but that's my point. Okay, so technically, when I take the square root here, b is both positive and -4. But can length be negative? No, so we would only take the value that is positive.
Positive.
That's my point, right? I need y'all to hear me again clearly on this. When you take that square root, you get a positive and a negative. But because we're dealing with side lengths, length has to be positive. Length has to be positive. Yes, Kais.
Is that b equal 4? Bottom right there?
Yes. Isn't that what we just said B was over there?
He wasn't paying attention.
Okay. Are we all good with how we figured out that Pythagorean theorem?
Yes, sir.
Can you please pick that up and move it away? Now, this next question is where actually most of us jump to, although apparently we didn't get there. When solving, or with your small group, identify an equation to find the indicated angle of number 1. I believe on that number 1, this was u, wasn't it? And that was the indicated angle? This is what I saw most of y'all trying to do originally. What trigonometric ratio can I use here? Sine. Listen to the question. We're trying to find the angle. What is the sine of angle u?
Divided by hypotenuse.
Opposite of u divided by hypotenuse, right? So we're trying to make sure we're as accurate with our notation as possible. So what side is opposite?
3.
Divided by the hypotenuse of 5. I need y'all all to pay attention to this because this is the thing that causes students the most trouble in trig, yet is super simple if you pay attention. What am I trying to solve? So remember, Matthew, the previous problem, we were trying to find the missing side length. That's when we use Pythagorean Theorem. We already know that b is 4 now, right? What am I trying to solve for? What am I trying to figure out? The angle measure of u. I've got an equation here, right? What do we have to use to solve equations? We solved an equation earlier. What did I have to use to solve this equation?
Pythagorean theorem.
So I used the Pythagorean theorem to start, but what did I use to solve that equation? Be careful, not opposite, although opposite is one of the, say it again, inverses. Notice how we had a positive 9. What's the inverse of that?
Negative.
A negative 9. So we subtracted 9 to make a
0.
0. Then we had b squared is equal to 16. What's the inverse of a square? A square root. And so we use the inverse to solve this equation. I have an equation here, so I need a what? I need an inverse. What would the inverse be?
Negative.
So be careful. Multiplication is the inverse of a what? Of division. So am I going to multiply here? No?
Yes, this is the inverse of division.
Dog, where do you see division? Oh, I see what you're talking about now. My bad. You're talking about this division over here, right?
Yeah.
Yeah.
But is there a variable on this side?
Oh, no.
Oh, you'll multiply by 5, right?
Matthew, listen to the question I just asked. is there a variable on this side? No. Where's the variable? On the other side, over here. What is with my variable that I got to get rid of? Sine. I have to get rid of sine. How would I do that? Negative sine? Okay, so this is what I want to point out. This is what I need you to hear me on. Listen. Again, this is what most students make a mistake on, so I need you to focus so you don't make this mistake. Are we multiplying by sine? That's not multiplication. It is the sine of that angle. So we're not going to divide because we don't have multiplication. We need the inverse of sine. Literally what the inverse of sine is called arc sine. Okay? This sine to the negative 1. This is called arc sine. Sine to the negative 1 is called arc sine, and that is the inverse of sine. I see a handful of us writing this critical detail down, and a bunch of us goofing off, or heads on backpacks instead of writing stuff down.
I don't.
Gabe, have you written any of this down?
Yeah, I was in my Bible.
Dude, what you been doing for the last 30 minutes? This ain't funny, man. This is your education, it matters. Sine to the negative 1 is called arc sine and is the inverse of sine. So what is it going to do to sine? It's going to kind of make it a 1, it's going to cancel it. Right? So be careful. Negative is the opposite. The opposite is when we have adding and subtracting to make it 0. We don't want a negative. We just want to cancel it. And notice, don't think of this as a negative. This is just a notation for an inverse. When you study Algebra 2 and higher level mathematics, we literally use what you think of as an exponent like this to indicate the inverse for certain functions. It's literally just the inverse. Remember, what does an inverse do? It cancels it out. So, if I have sine, I'm doing the inverse of sine to cancel. And I would just be left with what? U. But don't forget, whatever I do to one side of the equation, gotta do it to the other. I haven't done that yet, have I?
Nope.
Nope. So I take arc sine over here, and guess what? There is no way I would ever expect you to know arc sine of 3/5 off the top of your head. So how are we going to do it? Calculator. Anybody have a guess where we would go in the calculator?
Yes,
Probably go back to that trig button, right?
you got it right here.
So go to trig. Is there an option for arc sine right there?
Yes.
Yeah, so click on the arc sine and just type 3 divided by 5 into the calculator.
It's 36.86.
36.86?
Yeah.
Yeah, yes.
36.86 what?
Nah.
Not what I'm asking.
It keep going.
Remember, this is the measure of an angle. Say it again. Degrees. U is 36.86 degrees. You good with that? So I need y'all to hear me very clearly. If you can set up the equation, you can use your inverses to solve like normal. So if you can set up your equation, you can use your inverses to solve like normal. And I need you to hear me clearly on this because I do not want some teacher in the future to come back and say, Mr. Kinney, your kids don't even know how to read this. When you see this symbol, how are you going to say that?
Arc sine.
Arc sine.
Arc sine.
So remember, and that's what I want you to be careful about. That's not an exponent. It's indicating the inverse of sine. The inverse of sine is
Arc sine.
arc sine. So how would I read this? Arctangent.
Arctangent, yeah.
That's all it is. The inverse of tangent is arctangent. And this would be
Arc cosine.
arc cosine. Those are the inverses of sine, cosine, and tangent so that you can undo those operations. Alright. It is time, I would say we need some time practicing this on our own before we come back together and have a whole class discussion so you understand how to do it, right?
Yep.
So, let's do this. Alright, so today we're going to use trig to solve the right triangles. That's the sheet you already have out. We're going to do some more practice with it so that you have less homework to do on your own by Friday, but we do still have some more homework that we have to do by Friday. And hopefully with the last 20 to 30 minutes, we're going to start on what are called special right triangles. Okay? We're going to start on special right triangles. It's a different task, different package. By the way, I do want to point this out. Hey, look at your objectives again. What are we going to use to solve right triangles? Pythagorean Theorem and trigonometry. Okay. Remember, in the bell ringer, what two things did you need to solve for different values of the triangle? Trigonometry and Pythagorean Theorem. Every time you see right triangles, you should probably think about Pythagorean Theorem and or trigonometry. That is something to be aware of, especially for the ACT. It shows up regularly there. Ugh. Okay, but it shows up. But now that you know it, it's going to be a little bit easier. I promise you, Kelsey was wishing that she had all this geometry stuff before she took the ACT before, right? So, we already did a good bit of this yesterday, correct? Yes?
Yeah.
Yeah? Okay. We're going to do a couple more off of here today. But right now, I want us to work on these triangles, starting with what number do you think?
2.
Let's start with number 2. So, please notice here, does it ask us to find the missing side lengths?
No.
No. What does it ask us to do?
Angle.
Just the angle measures. For the sake of time, let's just stick with finding the missing angle measures. We'll do 1 or 2 where we solve the entire triangle. Sound good? But that'll be later. I want y'all to take 15 minutes, work with your small group to solve for the missing angle measures. What do you mean? So it depends. So I mean, all it is here I'm asking you to solve for that angle measure. But if I'm asking you to solve that triangle, you need to find all side lengths and all angle measures. So you found the side length, that'd be 4. And then we just found what that angle measure was, right? 36 degrees or so. And then you have to figure out what that angle measure is. But that's all you'd have to do. But right now, just follow these directions and find the missing angle measures. So I want you to get used to using the trig ratio. You're just finding that angle. See how it's Hey, clarifying point. Just make sure we're all clear on this. What angle are we trying to find in number 2?
A number.
I. See how it has this little mark here? That's the angle we're solving for. What angle are we solving for in number 3?
Z.
Z, where it's marked, okay? So I'm asking you to solve for those angle measures. Think about what we did with the bell ringer to help us get started with it. Yes, ma'am. So like when you take the arc sine, you need to take only there as well. And it's always the arc sine of the ratio, so that has to come first. So if you want to erase this in complete space or just rewrite it as a separate step. Just follow those directions. Amari, can I give this back to you? You can put it away and be responsible for the rest of the day? Or do I need to hold on to it until the end of By the way, Amari, you never did take this test. So you either have to take this test today or tomorrow. Tomorrow. Notice this is the transformation. One that was on similar figures, congruent models, reflections, rotations, all that stuff. So, you need to take this one here. It's better than a 0 though. She does know.
How do you solve for an angle?
You don't just magically solve for an angle. What do you need first? And E.
Bro, with
What equation should we be thinking about to find that angle measure?
Nah, you be calling them buckets and you be calling me them.
We might. Look at that angle measure right here. This angle right here. What do you have in respect to that?
John, that's I squared plus I squared.
Nothing?
Yes.
You don't have any side lengths though too? Anybody know how we can use those side lengths? I'm asking, what do I have in respect to this angle? Oh, I have the opposite and hypotenuse? So what could I use? Sine.
It's 12.
Write an equation using sine in those side lengths. Guys, you're not even like remotely trying. DD. You need to put the headphones away. Then it doesn't matter if they're put away. DD is being disrespectful.
No, you did not ask. I took my mind.
No. Because I've already asked you to take my ears multiple times and you put them back in.
You told me to take my one time.
No, it's been twice now. Before right now.
Because you keep looking at them. I ain't bothering nobody.
You're bothering me because I asked you to do something and you disrespectfully decided not to do it. Put them away. Just be aware, if they're not put up, it's right. Alright? What's giving you trouble with number 2? Huh? Hold on one second, let me stop the camera.
Oh my God.